if I want to calculate the net work done, so once I calculate the net work done, that is nothing but the change in kinetic energy delta T. This is nothing but the change in kinetic energy. So initially kinetic energy is 0, final kinetic energy, let us say K final. So that means that is nothing but the K final. Okay, K final number is this one. So now I am to simplify this number. So what I am getting, F square by 2m into T square. That is the okay. So today we'll start the work, energy and power. So there are three different topics under this chapter. First is work, then energy, then power. Now the similarity between these three parameters is that all of them are basically scalar quantity. So all are scalar quantity. So means they have to be added or subtracted in plain scalar addition or subtraction or multiplication, all are accepted. Now another thing is that the similarity between the work and energy is that both are having the same unit of joule. Okay, both are unit of joule, and power are having the unit of watt or joule per second, that is equals to watt. Okay. So now regarding the work, so work is said to be done only when the force applied on a body makes the body to move. That is, there is a displacement of the body. That means it is called the work done by a force. Written by the symbol like this here. So whenever there is a force applied on a body, so it will do some kind of work. Let us say there is a body which is resting on the ground. Let us say mass is 2 kg. So if I apply a force of, let us say, 10 Newton, so now this 10 Newton is acting on this body so that the particle will displace. Okay. So if I say there is no friction, so no friction is acting over here. So because of this force, there is an acceleration produced by the force that is equals to A, that can be written as F by M, that is equals to 10 by 2, that is 5 meter per second square. Now with this 5 meter per second square, the particle will move. Now if I ask to calculate what is the work done by this force, let us say in 2 seconds. That means I have to calculate the displacement produced by this force. So in 2 seconds, the particle will move by a distance, let us say S, that should be equal to half at square. If I say the particle starts from rest, so if the particle starts from rest, then ut plus half at square, u is becoming 0. So I am assuming that u is equal to 0. So it is half at square. So half a means 5 into t square means 4. That means 10 meter. So particle is displaced by a force, the force with a distance of 10 meter. So corresponding to this force, the displacement I got is 10 meter. So now I can calculate the work done by this capital F force, that is equal to how much? 10 into 10, that is 100 joule. Okay. So that means what you see that in this exercise, whenever there is a force applied on a body, if there is a displacement, then only I can calculate the work. Now how work actually calculated? There is equals to product of force and displacement. Okay. But one important fact about this calculation is that you also consider the angle between the force and the displacement. So in this situation, so the force is applied along the horizontal direction. So in this direction I am applying the force, and along the same direction the displacement takes place. So can I say that force and displacement both are parallel to each other? So that means the angle between the force and the displacement is basically theta, that is equal to 0 degree. Okay. So here theta equals to 0 degree because force and displacement vectors, these are the two vector quantities. These are parallel to each other. But that may not be the same in all the situations. So ideal definition for this is that it is called the Fs cos theta. Okay, so this is the proper definition of work done, where I say that work done by a force equals to F times S into cos theta. What is theta? Theta is the angle between the force and the displacement. Let us say in the same situation, if I say the ball is there, whose mass is again 2 kg, mass is 2 kg, and it has been applied a force of 10 Newton, let us say, and at a direction of, let us say, 30 degree. Okay, 30 degree. So let us say the direction is 60 degree. Okay. So for that situation, what happens? I have to take about the component of force that is acting along the horizontal direction. That should be equal to A cos 60. Okay. F cos 60. So F cos 60 is how much? That is 10 into cos 60. That is 5 Newton. Okay. Now the applied force along the direction of movement is equals to 5. Now corresponding to that, if I have asked to calculate the work done in 2 seconds. So what is the answer then? Now initially the entire 10 Newton force is applicable in the direction of the movement. But here now only the 5 Newton is responsible to create the movement. Now because of this 5 Newton, the acceleration produced is equals to 5 by 2. that is 2.5 meter per second square. Okay, and corresponding with that, again I can calculate A is equals to half at square, half into 5 by 2 into 4, that is 5 meter now. Okay, so displacement becomes 5 meter. Applied force is how much? There is 10 Newton. So in the second situation, I should calculate 10 into 5 into cos of 62. Okay, so that means 50 into half, that is 25 Joule. Got it? So depending on the angle between the force and the displacement vector, so the work calculation will be different. And one important point regarding the work calculation, you have to remember that work is always to be done by a force. Okay, so whenever the force is applied, then only I can calculate the work. So these boys are pulling or pushing the car in this direction A. So they are applying a force in this direction. Because of that, the displacement takes place in the same direction. So can I say theta is equals to 0 for this situation? Yes. So what is the work done by the applied force? That is equals to F into S. Okay. So depending on the angle theta, you have to calculate the work done by the. Okay. Now in some situation, it may be possible that you are applying the force. On the wall, you are applying the force in this direction, but the displacement is zero. So no displacement takes place. So one time applying the force, but there is no displacement. So that means the work done by the force is how much? That is equals to 0. Okay. So if we apply the force and if there is no displacement, then work done by the force is 0. Okay. So proper definition of work is this one: is the force into displacement of the point of application of the force in the direction of force. Now one of the keywords regarding this is the point of application. Okay. So the displacement of point of application has to be considered. Okay, let us consider one situation where let us say this is a wall. At the corner position of the wall, you are putting a block. Okay, you are putting a block of mass, let us say N. Now you are applying a force. Now this is a block. So I can say the block is not being moved. So what is the work done by the force? F is equals to 0 because block is being supported by the wall. Now in the second situation, you replace the block. Let us say I replace this block by a material which is made of sponge. So now again, if I apply the force, so there is no displacement of the block. But what I can consider that the point where the force is being applied at point A, so because of the force, the point A will be reflected in the direction. So now A is shifted to the point B because it is a sponge material which is soft material. Because of this force, the entire point A is shifted to point B. Though the block made of sponge has not been displaced, but what I can consider that the point A has been displaced to point B. So let us say this displacement is S. So work done by the force in this situation is not equals to 0, that is equals to F into S. Why? Because the point where you are applying the force, that is important. Okay. So that's why the key word is the point of application. At the point where you are applying the force, that is important. And it should be the direction of the force. Force should be in the direction of the force so that we can calculate the work. Okay. Now, whenever I am applying a force, the displacement takes place. So if I say the force is constant, so force is constant. So I can apply a force of 10 Newton, 20 Newton, which is not equals to very. If I pull the car with a force, constant force, and then what you can say the work done by this constant force. Work done by this force can be simply written as F into S into cos. Okay. But that is only applicable only when the force is constant. Okay. That does not mean that everywhere the force is constant, the force will be variable. If the force is variable, then the expression for the work is not so much simpler. It should be somewhat different. Okay. But in your syllabus, only the work done by the force is basically taken as the Fs cos theta, where you say that F number is constant. Okay. Let us say the guard is pulled by the string and string is applying a force which is constant. So every time I can say the force is in this direction and the displacement in this direction. Okay. So the angle between the force and displacement is theta. Okay. So in this situation, theta is not equal to 0 degrees. So correspondingly, proper value of theta has to be used to calculate the work done. Okay. Now, depending on different direction of motion, that means in the first situation, let us say I am applying the force in the upward direction and displacement takes place in the horizontal direction. So can I say the theta for this situation is 90 degrees? For the second situation, force is applied in the negative direction, delta x, or the displacement in the positive x. So now theta is equals to 180 degree. In this situation, theta equals to how much? Theta is the angle between the force and the displacement. So displacement in the negative x. So that angle has to be considered. This is 120 degree. Okay. This is equals to 120 degree. In the second situation, so displacement in this direction, so that angle has to be considered 60 degree. Okay. So theta is equal. So depending on the various situation, the theta number will be different. And accordingly, I can calculate the work done for different situations. So for the first case, cos theta equals to 90 degree, so cos theta becomes 0. Okay, cos 90 is 0. 1 theta equals to 180 degree, cos of theta should be equals to minus 1. 1 theta equals to 120 degree, cos of theta equals to minus. And when theta equals to plus 60 degree, cos theta equals to plus 1 half. Okay, so that means the cos theta number is going to be changed in every situation. So since the cos theta number is changing, and if I say, let us say in this situation, if I apply force of 10 Newton and delta x equals to, let us say, 2 meter, so work done will be different in the different situation. Okay. First situation, work done should be equal to 0. In the second situation, it should be equal to minus 20 joule. In the third situation, work done should be equal to minus 10 joule. And here it should be plus 10 joule. Okay. So depending on the various angle between the theta and various angle between the force and the displacement, the calculation of work will be different. And what you can understand from this situation is that the work can be positive, negative, or okay. So when the work is positive, when the work is positive, that means in that particular situation, the theta angle should be always be the angle which is less than 90 degree, that is acute angle. Okay. When the theta angle is the acute angle, then only I can say that cos theta is positive, and in that situation, I can say that the work is being positive. Okay. And if I say theta equals to 90 degree, theta equals to 90 degree means cos is 0. That means in that situation, work is always going to be 0. Okay. And whenever the theta is acute angle, whenever the theta is obtuse angle, that is greater than 90 degree, then cos theta is negative, that is work done is negative. Okay. So depending on the theta angle, every time you can check whether the angle is positive or negative, and depending on that, you can comment what is the work done. Okay. Now there are certain situations regarding this. So if the displacement is in the direction of force, that means theta equals to 0 degree. I have already discussed. So in this situation, what is happening? Let us say the ball is being dropped. So in this situation, the ball is being dropped means weight of the ball, that is mg, is acting downward, and displacement is in the same direction, s. So can I say theta equals to 0 degree? So here the force is mg, that is the gravitational force. So work done by gravitational force should be equals to mg into s into cos of 0 degree means 1. Okay, that means work done is going to be positive work. Okay, so in this situation, when the theta is equals to 0 degree, so work done is always positive. So when the work is being positive, when the work you are getting the answer of work as positive, that is what is the conclusion? Conclusion is that the speed of the body will increase. Speed of the body will increase. Okay, if the work done becomes positive, that means the speed of the body will increase. Now, let us say in this situation, the man is pulling a load. Okay. So whenever the man is pulling a load along the inclined plane, let us say angular of inclination alpha. So this is the load that has been lifted with this force. Okay. So for this force, A, what is the direction of displacement? So he is applying the force along the inclined plane, and displacement is also in this direction S. Okay. So can I say theta is equal to 0 degree for A? But if I consider the weight of this body, so weight is acting downward, mg is acting downward. So for the mg force, the theta is how much? Theta is now obtuse angle, this angle. What is that angle? That is 90 plus alpha. Okay, and that is greater than 90 degree. So what I can say that in this situation, there are two forces that are acting on this body. One is the A, with which the man is pulling the load along the inclined plane. Another is the weight of the body itself. So work done by mg force, if I want to calculate, that must be negative one. Why? Because I am getting the feeling that the displacement and force is making an angle which is 90 plus alpha, that is greater than 90 degree. So work done by mg will be negative one, but work done by the force should be a positive one. Why? Because in this situation, theta is equal to 0 degree. So on a particular body, different forces may be acting. On a particular body, different forces may be acting, and depending on that, you have to calculate the work done by each and every force. Okay, by each and every force. So let us say on a particular body, let us say F1 is one force is acting, another force is F2, another force is F2, like this, different forces are acting. So corresponding to the F1, you can calculate the W1. Corresponding to the W2, W3, one may be positive, one may be negative, another may be zero, whatever is the situation. So value of W1, W2, W3 can be evaluated if I know the value of F1, F2, and corresponding displacement. So once I calculate all the work done, then based on that, what you can calculate the net work. What is net work? Net work is nothing but the summation, simply summation of this W1, W2, W3. Why? Because these are the scalar quantity. So I can add W1 plus W2 plus W3 like this. All the numbers can be added up. And once you add this number, I can get the value of net work. Okay. So once I am getting the net work, that net work may be positive number, maybe negative number, maybe zero. All three possibilities are there. So depending on the situation, whether I am getting the net work is positive, I can calculate that velocity or the speed of the body will increase. Negative means speed of the body will decrease, and zero means speed remain constant. So there is no change in the speed. Okay. So this is the final conclusion. So whenever I want to calculate the work, that means I have to be very careful regarding the identification of the force. What are the different forces acting on the body and for which force I want to calculate. Okay. Let us say this is the situation where there is a nucleus of positive charge and there is an electron which is orbiting around this nucleus, which is a negative charge. Okay. Now, this is a electron performing a circular motion, and in that circular motion, what is happening? I know that toward the center there is one force is acting, that is called the centripetal force. Okay. So displacement is always tangent to this path. Okay. Displacement is always tangent, so that means 90 degree angle. So at whatever the location the electron is there, so displacement is always tangential to this path. This is the S and force is in this direction. So can I say this angle is always 90 degree? If the angle is 90 degree always, what I can conclude that work done by this force is always going to be zero because cos 90 is zero. So this is work done by the force is always zero. Okay. So the forces which are producing the work done to be zero because of the situation that in this situation theta becomes 90. And for that situation only, what I can say that W becomes 0. So now force is not equal to 0. In this situation, I cannot comment that force is not equal. Okay. So the force which is responsible to produce no work is called the no work force. No work force. So this type of force exists in nature which will not give any kind of work. Why? Because for these forces, the displacement is always tangential to the path and force becomes perpendicular to the path. That's why these forces are known as the no work. Okay. Let us say this boy is lifting a load. Okay. So the bucket will be lifted with a force of F, let us say. Okay. So the boy is moving in this direction. The displacement in this direction. Okay. So work done by the force is equal to how much 0? Why? Because the angle between F and S clearly is 90 degree. Similarly, if I say here another force is acting, that is the weight of the bucket, W. Okay. So it is equal to mg. So for this mg force, again the displacement is 90 degree. So work done by gravity is also 0. Okay. So every time you have to understand the situation, what is the force and what is the direction. Okay. Depending on that only you can calculate what is the work. So condition for the work done by the force to be 0. So under what condition the work can be equal to 0? First one is that when there is no displacement. You are applying the force. Let us say the body is placed at the corner of the wall. So you are applying the force, but still the body is not giving any kind of displacement. Here is equals to 0. Okay. So in that situation, I can say the work done by the force is equal to 0. And another situation is that the displacement is perpendicular to the direction of it. Okay. Like in the case of circular motion, what I can say, whenever the body is performing circular type of motion, so there is one force that must be acting as the toward the center, it is centripetal force. Okay. And corresponding to that displacement is always 90 degree. With the S, so this angle is 90 degree. So this force is giving the 0 work. Okay. So either the displacement will be 0 or the angle will be 90. So under these two situations only, the work done by a force may be equal to 0. Now, if the displacement is in the direction which is opposite to the direction of the flow, that means this guy is pulling or pushing the block. Okay. He is trying to push the block with a force of, let us say, F. But the block is not moving. Why? There is friction. On the side, the friction is there. The friction is trying to oppose this. Friction is trying to oppose this. So friction is trying to oppose it. So I am applying a force of capital A. Friction is providing the equal and opposite force of small a. If I say capital A is less than the small a, then the body will not. No movement. So if I want to move the block, that means the X number should be greater than small a. So if capital A is greater than small a, then the body will move. Okay. So once the body is moving, let us say in that situation, so on the floor, let us say the body is moving because we applied a force of capital A, which is greater than small a. Okay. If I apply a force which is greater than small a, then the body will move in the forward direction. So let us say this is the direction in which the body is moving displacement. So if I calculate the work done by capital A, that should be equal to F into S, that is positive number. Okay. Now work done by small a, that is the work done by friction. So friction is acting opposite to the direction of the displacement. So I should write F into S into cos of 180. And I know that cos of 180 is equal to minus 1. So answer should be minus F into S. Okay. Minus F into S. So in that situation, what is happening that applied force, that the capital A, that is called the external force. I am applying this force. I am applying this capital A. So that capital A is known as the external. This is the external force. And small f is the friction force. Okay. So what you understand from this exercise is that the work done by the capital A, that number is positive. And work done by small f is negative. So if I add these two numbers, so that will be the net work. Okay. The net work will become positive. So in this situation, net work will become positive. And for that situation, what you can say, the velocity of the body will increase. Okay. It implies the velocity of the body will increase. Then let us say in that situation, let us say on this block, let us say I am doing the same calculation. Let us say mass is 2 kg. Okay. We applied a force of 20 Newton. That is the external force. Let us say friction acting over here is 6 Newton. Okay. Friction acting over here is 6 Newton. So you are asked to calculate what is the work done by this capital F and by this small f in 2 seconds. And work done in 2 seconds. So first of all, you have to understand that in that situation, the body is moving. Why? Because 20 is greater than 6. That is body is moving. So since body is moving, so I want to calculate what is the displacement produced by this body in 2 seconds. So for that, I have to calculate the acceleration. Now, what is acceleration? Acceleration equals to net force by mass. Net force by mass. What is the net force? 20 is the positive one and 6 is the negative one. So can I say 20 minus 6 by 2? 20 minus 6 is 14 by 2 means 7 meter per second square. So 7 meter per second square is the acceleration produced by the body due to the application of 20 Newton force. Okay. And because of the 7 meter per second square acceleration, can I say A is equal to half it square again? That means half into 7 into 4. That means 14 meter. Okay, 14 meter is the displacement. Okay. Now we can calculate the work done by capital F. Work done by capital F is how much? 20 into 14. Positive 280 joule. Okay. And work done by small f, that is equals to minus 6 into 14. Why minus 6? Because the friction is acting in the opposite direction. That means it is equals to minus 84 joule. So once we add these two numbers, what I am getting? The net work. So net work is how much? 280 minus 84. That means 196 joule. So this is the net work done by the force. What are the forces? 20 is the force, one force, and the force is the friction. So once I am getting the idea about the net force, net work, what I can conclude that since I am getting the net work is positive, so I am getting net work is positive, it implies that the velocity or the speed of the body will increase. Okay. So net work is basically increasing the speed. That means it is increasing the kinetic energy. Okay. Increase in speed means increase in kinetic energy. So net work is converted to the kinetic energy. Okay. So regarding the friction, there may be two types of friction. One is called the kinetic friction and called static friction. So what is kinetic? Kinetic means when the body is moving. Okay. Let us say the body is moving on the surface. So in the earlier example, what I say that this force, I have applied a force of 20 Newton on this body, and the friction is occurring by, let us say, 6 Newton. So that means in this situation the body will move. In this situation the body will move. So since body is moving, so that friction acting on the surface is known the kinetic friction. And if I say in the same situation, if I apply a force of 5 Newton, if I apply a force of 5 Newton, then the friction will be adjusted to 5 Newton again. Why? Because maximum value of friction is 6 Newton. If I apply 6 Newton in the opposite direction, that means the body will move in the opposite direction. That is not true. Okay. So if I apply a force of capital H equal to 5 Newton, then the surface is going to provide another resistive force of 5 Newton equally in the opposite direction. Now the body will be at rest. So since the body is at rest, so this friction acting on the surface is known as static friction. Okay. So this is the difference between the static and kinetic. So whenever the body is at rest, the friction acting on the body is acting as a static friction, and when the body is moving, the friction is kinetic. Okay. Now there is another variety of friction, that is the rolling friction. So rolling friction means, so you are trying to roll a body over a surface. So let us say whenever I am saying rolling, the body may be circular one. Okay. So let us say there is a circular object, you are trying to roll this body. So for that, what you do, you have to apply a moment. So if apply a force A on this particular body, so about this O point, I can give a moment, and because of that, I can know that the body is rotating. So whenever the body is rolling over a particular surface, the friction offered by the surface is called the rolling friction. Okay. So there are 3 types of friction that can be existing in nature. Apart from that, there are another type of friction that is called the fluid friction. So if the body is moving on a surface, so lowest friction possible is the fluid. So if I say rolling friction is the minimum value of friction, then the kinetic friction, then the static friction. Fk means the kinetic value. Okay. And it is in the static value. So static friction is the maximum possible friction offered by the surface on the. Okay. So rolling is easier. Why? Because in case of rolling, the friction offered is less. But you want to push the object. So same object, if I try to push you, then the force applied will be more. Once I am pushing the object, so let us say this is a circle of the same circular object lying on the circle. If I apply a force, it is passing to the point 2. Now this force has no turning it. So now with this particular force, I am trying to push the object. So whenever there is a feeling that I am pushing the object, now the surface will give a frictional force, which is basically of Fs, static friction. Plus, now until and unless I give a force which is greater than the Fs, the body will not start the movement. Okay. So now in order to start the movement, you have to apply greater amount of force. Why? Because Fs value is the maximum. Okay. So it is easier to roll the, but again rolling is particularly term defined for the circular one. So if the object is not circular one, that means you cannot roll it. Okay. You cannot roll it. So for a circular object, the concept of rolling is there, and I understand that the rolling friction is not less than the static friction. Okay. Now come to the concept of force versus displacement time. Okay. Let us say in this situation a ball is moving upward and downward. That means you throw the ball from the ground. You throw the ball from the ground at a certain speed, and the ball will move upward and then it will come. Okay. So in the whole process, so let us say I am saying A to B. A to B. So when the part is moving A to B, so force acting on the body is basically the weight of the gravity. So gravity is acting downward mg. Okay. And displacement is upward. Displacement upward. So when the part is moving upward, so gravity is acting downward and the displacement is A to B means upward. And I can say clearly the angle theta is now the 120 degree. Now when the body is coming down, so mg is acting downward and displacement is also in the same direction. Now in the second situation, theta becomes 0 degree. Okay. So during the upward movement, theta is 180 degree. During the downward movement, theta becomes 0 degree. And theta becomes 180 degree in the upward movement. That means work done by the mg force. Work done by the mg force, gravity force in moving the particle from A to B is going to be negative because theta is 180 degree. And similarly, work done by the gravity in moving the particle from B to A. B to A means downward movement is going to be positive. Okay. Now I can feel that situation work done by force is negative, means the speed will decrease. It implies that the body will decrease. But once I throw the ball, as the ball is moving upward, so gradually the velocity will decrease. Ultimately, one point will come when the velocity becomes zero, and from that point the body will come down again. So during the downward movement, I am getting the work done to be positive. So work done to be positive means the velocity will increase. So once the part is falling down, I know that the velocity is increased. Okay. So now I want to plot a diagram of force versus displacement. If any kind of diagram between the force versus displacement is given to us. Okay. So on the y-axis I am plotting the force, and on the x-axis I am plotting the displacement. So if a diagram is given like this, now if I calculate the area under this, that will be the work. That will be the work done. Okay. So if it is a triangular shape area, I can calculate the area of the triangle. If it is a rectangular area, then I can calculate the area of the rectangle. So depending on the situation, I can calculate the area. And once I am calculating the area, so that area is basically giving the value of work. Okay. Now let us say in this particular situation, the force is initially 0. So as the displacement increases, the force is going to increase. So that means I am discussing about a force which is variable in nature. It is variable force. Okay. So force may be variable, force may be constant also. If I plot the diagram, if I am able to plot the diagram, let us say I am drawing a force versus displacement diagram like this way. So a diagram of like this. Okay. So let us say the 10 Newton force, this is a 2 meter distance, then this 4 meter, then this 6 meter, and let us say this is a 10 Newton again. Okay, so there are two areas. One is the below the s-axis and the above the s-axis. So I have to define this area. This green area is a positive one. Is a positive area. Okay, and the area below the displacement axis is termed as the negative. So this is the negative area. Okay, so for this, if I calculate the first area, so first area is how much? So it is a trapezium. So sum of the parallel sides. Okay, so first side is 2. So 2 plus 4 by 2 into distance between them is 10. Okay, so 30 joule. So 30 joule is the positive area. And for the lower part, if I calculate the area, half base into height. So base is 2, height is 10. So half base into height is 10. That means 10 joule. But that 10 joule should be negative. Okay, so net work, W net should be equal to 30 minus 10, that is 20. Okay, so that can be calculated only when the area is calculated. Once I calculate the area, that means it is giving the area, and that information is work. So work is positive, work may be negative depending on the area. So area above the s-axis is the positive, area below the s-axis is negative. Okay. Now regarding the unit of work, SI unit of work is joule. So 1 joule equals to 1 Newton into 1 meter. Okay. So 1 joule basically equals to 1 Newton into meter. And in CJ system, 1 Newton equals to 10 to the power 5 times. Okay. And 1 meter is equal to 10 to the power 2 centimeter. So simply I can write 10 to the power 7 dyne centimeter. And dyne centimeter is another unit in the CJ system known as the R. Okay. So 1 joule equals to 10 to the power 7. This is the conversion of SI to CJ system of unit. Okay. So now come to the power. So once we define the work, now we define the power. So what is power? Power is the rate of doing work. How much amount of work you are doing and what is the time required for that. Whenever I am doing your work, I need some kind of time. Okay. So earlier situation, if I say, let us say I am acting a force of 20 Newton on this body of 2 kg. Okay, assume there is no friction. So I calculate what is the displacement in 2 seconds. So for that I calculate the acceleration. What is the acceleration? 20 by 2. This 10 meter per second. And correspondingly I calculate what is the displacement. So what is displacement? Displacement equal to half 80 square, half into 10 into 2 means 4 means 20 meter. Okay. And correspondingly I calculate the work done, that is equal to 20 into 20. That is 400. Okay. Now my question is, how much amount of work is being done? That is 400. Now what is the time required for that? I calculate the work done in 2 seconds. I calculate the work done in 2 seconds. So what is the 2 second term? That is the time. Okay. After 2 seconds, I calculate the what is the work done. So I want to calculate the rate of work. It is called the rate of work done. Rate of work done means you are doing 400 joule of work in 2 seconds. So 400 by 2, that means 200 watt. So that will be your power. Okay. So now in this situation, if I want to calculate another term, let us say I want to calculate what is the speed of the particle after 2 seconds. The V number. So for that I should use V equals to U plus 80. If it is 0, A is how much? 10. A is actually 10 and P is 2. So 10 into 2 means 20 meter per second. Okay. So I can calculate the velocity as 20 meter per second. Corresponding to that, if I multiply 20 into 20, that means I am getting 400. So that is the same answer that I am getting for the work. Okay. So there are a different way to calculate the work as well as power, but main idea is that whenever you are willing to calculate the power, you have to calculate the work done first and then how much amount of time is required to do that. In some situation, you can also take this value t as 1 second. That will help to solve the problem. That means power can also be written as the work done in 1 second. Now, how much amount of work you have done in 1 second, that will also give the information of the power. Okay. So power is the rate of work. So power is, so there is the electric bulb. So electric bulb is basically I am supplying the current energy. I is supplied and there is a filament. So in that filament some kind of resistance is there and there is another line through the same amount of current is going out. So I know that in this situation what is happening that whenever I am supplying the current, some amount of heating takes. So because of that heating is known as joule heating, that is the I square R. That is the heating part. So that heat is basically the energy. That heat is basically energy and that is nothing but the work. Okay. So corresponding to the heat energy, now I want to calculate the power. So power is basically what? I square R into T divided by T. That means I square into. Okay. So that is the power rating of the bulb. That means I am supplying some kind of energy. What is the energy that I am supplying? That is the electrical energy. And bulb is going to convert it in terms of light energy. Okay. Light energy, heat energy, sound energy. Maybe like that. Light energy or heat energy. Okay. So from the conversion of one form to other form, I have to supply some kind of power. So what is that power? I am giving as electrical energy as a, that means I am doing I square RT amount of watt per unit time. So once I got this I square RT information, that is the energy that I am supplying and what is the amount of energy I am supplying in 1 second. So that means I have to divide it by time. So that will give the information of the power. Okay. Similarly, this is the situation. Yeah. So there is a water wheel. So in the water wheel, what I am doing, I am taking the water at a certain height. So water is kept in the reservoir or dam. Okay. So this is the water. So water is stored at a certain height. That means water having some kind of energy that is called the potential. Okay. So water has the potential. When you allow the water to flow through this pipe, so at the outlet of the pipe, what I am getting, the energy as the kinetic. Kinetic energy to the water. Now this kinetic energy is being utilized to run the water. That means this high intensity jet of water is impinging on the bucket. Okay. Once they are impinging on the bucket, they are giving a thrust, and because of that thrust, the wheel will roll. That means I am converting this kinetic energy water to the mechanical energy of this drum. Okay. Now this mechanical energy of the drum is connected to another pulley system with a chain mechanism. So this is the belt. Let us say I am transferring this kinetic energy of the mechanical energy of this wheel rotating drum to the another wheel. Now with that wheel, I am connecting a particular green colored instrument. That instrument is basically the generator. So the AC generator. Okay. Now what is the function of AC generator? So as a input AC generator, I am giving the mechanical energy. Okay. And that energy is being converted to basically the electrical form of energy. So that is the function of AC generator. So once I am converting it, that means I am essentially converting one form of the energy to the other, so that I can glow the light. Okay. So this is the entire process where the energy is being converted from one form to other. Okay. Let us say there are two situations when I am lifting one book with a time of delta. Okay. and I am lifting the same book very slowly. That means now the time is more. Here I am lifting the same book in let us say 10 seconds. And here I am lifting the book at a time, let us say 30 seconds. Okay. So first of all, calculate what is the work done. Let us say I am lifting the book from this point to this point, and that height is, let us say, is equal to 2 meters. Okay, I am lifting the book by a height of 2 meters. Okay, and for that, how much I want to work I have to do? I have to lift the weight. So let us say weight of the book is 2 kg. So mass of the book is, let us say, 2 kg. So what work I am doing in lifting the body? So work is basically mg into h. Okay, mg is the weight and h is the displacement. So that is 2 into 2 into 10. That means 40 joule of work. Okay, so in both the situation I am doing the 40 joule. Okay, in both the situation I am doing the 40 joule, because in the second situation also I am lifting the same book with the same height. That means here also work is 40. But the difference between these two work is that one work is being done at a slower time and another work is done at a faster time. Okay, so corresponding to the power in the first situation, if I calculate the power in the first situation, that's 40 joule of work is being done in 10 seconds. Okay, in the second situation, power is 40 joule of work is being done in 30 seconds. Okay, so that is the difference between the power. So in the first situation, I am getting 4 watt of power. In the second situation, I am getting 4 by 3 watt of power. Okay, and the power is dependent on not only how much amount of work you are doing, but at what time you are. The time is important. Okay, so both the persons are doing the same work, but the time requirement for both the persons are different. That's why the power is different. Okay. Now come to the energy. So energy is nothing but the work. So whatever be the amount of work that you are doing, that is nothing but the energy. So energy is the body capable of doing work is said to possess some kind of energy. Okay. Now regarding the energy, mainly consider only two types of energy, that is the potential and the kinetic energy. So energy possessed by a body is measured by the amount of work. So work and energy both are same. How much amount of work is being done, that is nothing but the energy. Okay, let us say I am repeating the same situation where I have said that if the mass is 2 kg, 2 kg block is being pushed by a force of, let us say, 20 Newton, and I calculate that the work done in this situation, work is basically equals to 400 joule I got in 2 seconds. Yeah, in 2 seconds. That is the answer that I got. Then this is the amount of work that has been imparted on the block. Okay, who is doing this work? The capital F is doing that. Okay, now what is the effect of that? That means with that work, the body is increasing some kind of energy. Okay, so amount of work that I am doing on the body is stored in the form of some kind of energy inside that. Okay, so that is the conversion. So equally, if I say there is no loss, that means the surface is smooth. This surface is smooth, that means I can say the surface is not going to lose anything, or energy or work will be not, any work is not negative. So what I can say, the entire work is basically utilized to increase the energy. So that means at this final position after 2 seconds, the body has the energy which is called the kinetic energy. Okay, initially the body is at rest. Initially the body is at rest, and then the kinetic energy is 0. So until and unless I apply some kind of work or I apply some kind of force, the force is doing some kind of work. Because of that, the kinetic energy is going to be increased. Okay. So in this situation, what is happening? Once we stretch the string, so this is the string that is a stretched position. So now we can go in this direction. Now once I stretch the string, so there is some energy being stored inside the string. We call the potential energy. We call the spring potential energy. So once I release my hand, the entire potential energy that has been stored inside the string is going inside this bow. So that is conversion of potential energy to the kinetic energy. So because of that, the bow is going in the forward direction. Why? Because some amount of energy is imparted on the bow. Who is imparting that energy? The string. So once I am pulling the string, that means the energy is being stored inside the string. And that energy is going to utilize as a form of kinetic energy once I release it. Okay. So energy is being converted from one form to another form. So let us do some exercise. A force of 10 Newton displaces a body by a distance of 2 meters at an angle of 60 degrees in its own direction. So that means direction is set. Okay. We are applying a force of 10 Newton and the body is being displaced by 2 meter, what is 2 meter distance, and angle of 60 degree to the own direction. So that means 10 Newton is acting in this direction. Okay, 10 Newton is acting in this direction. So that the angle is 60 degree. We are asked to calculate the amount of work. So work is equal to 10 into 2 into cos 60 degree. Means 10 Joule. Okay. Now in this situation, there is a force of 50 Newton is required to pull up a body. Yeah, force is required to pull up a body of mass 2 kg through a distance of 5 meter along an incline. So angular inclination will be horizontal. You are asked to calculate the work done by the force in pulling the body. So this is the force that has been applied. 50 Newton is the force applied on this body. So you are asked to calculate the work done by the force. Okay, work done by the force. What is that force? So for 15 Newton, what is the displacement 5 and what is the direction? It is equal to 0 degree. Why? Because both 15 Newton and the displacement A is equal to 5 meter, both are aligned with themselves. That means in this situation, theta is 0 degree. Okay. So work done by 15 Newton should be equal to how much? 15 into 5. That is 7.5 Joule. Okay. Understood? So in the same situation, if I ask to calculate, what is the work done by the gravity force? So for this situation, gravity is acting downward and this point is displaced from A to B. What is the displacement? So vertical displacement is this. Okay. Either you can take this displacement or I can say mg is acting downward and this point is shifted to this point, B point. Okay. Now this is the displacement. That is 5 meter given. So that angle has to be taken into consideration. Either you can take this angle is how much? If this angle is 30 degree, then this is 60 degree and this is 120 degree then. Nah, this is 60 degree. That should be equal to 120 degree. And I know that cos of 1 degree minus 1, minus 1. So work done by this mg force, should be equal to what? Mg into 5 into cos of 120 degree. Okay. Mass of the body is given as 2 kg. Mass of the body is given as 2 kg. So 2 into g means 20. 20 into 5 into minus 1. Minus 10 minus 52. Okay. So work done by the gravity is negative. So either you can calculate in this way or you simply calculate the vertical distance between point A and B. Okay. This is vertical distance. So this is the right angle triangle whose height is 5 meter, hypotenuse is 5 meter, this angle is 30 degree given. Okay. So vertical distance is sin 30. So sin 30 should be equals to the vertical displacement, let us say x by 5 then. Okay. So x becomes how much? 5 sin 30. Means half 5 by 2. Okay. So this is the displacement of this point. Now simply multiply with mg. But be careful that since x is upward, mg is downward, we should put a negative sign. So work done by gravity, mg should be equal to mg means 20 into 5 by 2 into minus sign. And then again we are getting 50 with the negative sign. Okay. So either you can solve it in this way or in the other way, both will be the same answer. Okay. Now these are the same numerical, you can calculate that. Okay. Now moving on to the another segment of the energy that is called the potential energy. Now we calculate the what is the potential energy. Now potential energy is symbolically defined by the symbol E, capital E. So it is defined as the energy possessed by a body by virtue of change its position or configuration. This is called the potential energy. Okay. So whenever I change a position, that means the potential energy. Let us say the body is resting on a ground. In mass. So it is at point A. If I want to raise the position to point B, let us say it goes to point B. That means I am changing the position. Now in that situation, how to calculate what is the potential energy? So in order to calculate that, first of all, you have to calculate the work done by the gravity. So in this situation, if I move the particle from A to B, work done by the gravity, let us say this distance is h. So mg is acting downward, and h is upward. So can I say work done by the gravity is equal to minus mgh? Why? Because both are opposite to each other. Okay. Now, potential energy is basically something equal to U, that is negative of this word. Okay, negative of this word. So if I put a negative sign before the word, it becomes plus mg. That means potential energy of the body, once it goes to point B, it is been increased from 0. So whenever the body is placed on the ground, I assume the potential energy is equal to 0. Okay, 0 potential energy. So if I move up to a point B, then the potential energy on the body at point B, let us say in the UV point, so UV will be how much? mgh. So that means it will increase the potential. Okay. So potential energy is increased if I go from point A to point B. If I move down, let us say, if I increase the height, so if I move from ground to in the upward direction, it will increase. Because the potential is going to be positive. If I move in the downward direction, the potential is going to be negative. If I remain on the same horizontal line, the potential remains same. That is zero. Okay, there is no change in the potential. That means you have to change the position. So if I say I am remaining on the ground itself, that means I am not changing my position. If I don't change my position, then there is no potential. Once I change the position, then the potential will be there. So potential is again can be positive, can be negative, can be zero also. Okay. And this potential is known as the gravitational potential. This potential is known as the gravitational potential. Now, so this person is getting the ball to be released at a particular position. So there is a ball tied with a thread, and the thread is fixed at this position. So once he releases the ball, that means the ball is going downward in this direction, and then going upward, and then again coming. Okay, rotating down. That means what I can say, initially the ball, let us say at A point, it releases. So ball is going downward. So once the particle is moving downward, that means the potential energy is released, decreases, and then again it increases. So let us say from A to B, it goes, then from B to C, it goes. Okay, so during the movement A to B, potential is decreasing. So potential is decreasing in kinetic energy increase. Okay. Now B to C, it is rising up. So that means potential will increase and kinetic energy will decrease. Okay. So at any point of time, the total energy is always constant. So once the particle is returning back, once the particle is returning back, so at a point, so there is no kinetic energy because the person is releasing the ball. Okay. So he is releasing the ball, that means it has no kinetic energy, he just releases. He just releases his hand, so ball is moving down. So at point A, the kinetic energy is 0. Okay. Now similarly, the ball goes to point C. At point A, again kinetic energy is equal to 0. So what is the total energy at point A? Total energy at point A, nothing else, summation of the kinetic plus potential. Now at point A, there is some kind of potential is there. Okay. So if I calculate the total energy at point A, let us say total energy is equal to U plus K number, and that is equal to 10. Let us say. So that means at each and every point, the position, the particle should have the energy of 10 Joule. So once the particle is coming back, it is not hitting the mat. Okay. Carefully, if you look, the point up to which the ball is reaching is less than the initial. Initially, he is releasing the ball from his chin, but the ball is coming back to a point which is less than its chin. Why? Because that means the ball is not reaching up to point A. That means in the process of the movement, the ball is losing some kind of. Why? Because ball is tied at this point O. So at this point O, some kind of friction is. Okay. So because of friction, the ball is losing the energy. That means what we can ensure that if I release the ball from my chin, a heavier ball is there. If it comes, it will break. That means the ball is not reaching up to the point, so mind becomes safe. Okay, he's being not in. So this is a classical example where you can consider how the energy is being changed. Okay, how the energy is being changed. And in real life situation, total energy can never be constant. Why? Because some kind of loss is always. Whenever there is a body is there and the body is moving or something is happening, so because of some amount of energy loss, total energy is not going to be constant. But what you can say, the conversion of one form of energy to the other form of energy is being taking place. Okay. Similarly, the situation over here also. So the block is connected with the spring. Now there are two types of energy potentiality that we have to discuss over here. One is called the gravitational potentiality. That is simply written as the mgh. Okay. And there is spring potential. Spring potential, that is basically written as the half x square. So what is x? X is the basically the elongation or compression of the spring. So whenever there is a spring, so if no force is being applied on the spring, let us say the length of the spring is called the natural. Yeah. When there is no force is being applied on the spring is natural. So let us say the natural length is 10 cm. So you purchase a spring from the market and you measure the length of the spring and that is 10 cm. Now once you are pushing the spring or pulling the spring, the spring length is going to change. Okay. So whenever you are extending the spring, let us say I am extending the spring by a distance of x. X is measured from the natural length. Let us say this is 1 centimeter. Okay. So corresponding to the what is the potential energy inside the spring, that will be written as half x. Okay. Half x square. What is the x? X is the elongation. Or similarly, if I compress the spring from this point to that point, then it is also even half x square. Okay, half x square. So half x square, this term is the term that is known as the spring potential. And what is K? K is called the spring stiffness. K is the spring stiffness. What is that number? So if I say do the spring, if I do the spring of length, let us say 10 centimeter. Okay. Now, let us say at this point, A point, we are applying a force of let us say 10 Newton to increase the length of A point by 1 centimeter. Okay. So now we can define the concept of K. Now what is that K? K is basically amount of force required. How much force I am applying? 10 Newton to produce the unit elongation. What is the elongation? 1 centimeter. But if I convert the 1 centimeter, so 10 divided by 1 by 100, that means 1000. That is Newton per meter. That is the answer for the K. So K is called the stiffness of the spring. That is the amount of force required to elongate the spring by unit. Okay. So two different spring having different value of K at different stiffness. Let us say there is one spring Ka is given as 50 Newton per meter. And the spring is there. Let us say the spring constant is Kb, that is equal to 100 Newton per meter. By seeing these two numbers, what I can conclude that for the B spring I have to apply more amount of force compared to A spring. That means what you say that B is more stiff. More stiffness. More stiffness means higher the value of K. So K is called the stiffness coefficient or stiffness constant. Okay. Or spring constant, that is the basically property of the spring actually. So by which material the spring is made, depending on that, what I can say that is called the stiffness constant or spring constant. So whenever the block is moving, so block is moving means block has some kind of speed and corresponding to the speed, the block has a kinetic energy. Once the block is moving towards left hand direction, the spring is being compressed. So entire kinetic energy of the block is converted to increase the spring potential. Okay. And whenever the block is moving towards right, that means now the spring is being relaxed state, that means it is trying to lose the energy. That means now the energy of the potential energy of the spring is converted to the kinetic energy of the block. So that is again the conversion of energy from one to the other. Okay. So like this way, there is different arrangement of the spring. So once I say the spring is there, so there is a spring potential energy that is half x square. Okay. The spring has a potential energy of half x square, U for the spring. And by seeing this number, what I can conclude that this number can never be negative. Why? The term is x square. So this value is either positive or 0. But for gravitational potential energy, U equals to mgh, that number can be positive, that number can be negative, that number can be 0. Okay. Why? Because h can be positive, can be negative, or can be even 0. But spring potential is always positive or 0. Why it becomes 0? Because when that there is no elongation. If x equals to 0, no elongation, no compression, under that situation only spring is having the 0 potential energy. Okay. Now, gravitational potential energy at a height of that means U equals to mg, that means what I have said already, that if I raise the particle from point A to point B, the potential energy will be increased up to point B. Okay. So at any position, let us say I am moving up to X position. So at X position, U at point C, let us say that is equal to mgx. U at B should be equal to mgh. That means what you can consider that as x increases, the potential is also increasing. So if I plot the variation u versus x, u versus x, if I go from x equals to 0, x equals to 0 means ground. So if I increase the length, the potentiality is following this equation. That is a simple straight line equation. Y equals to mx, where m is the slope. The slope is what? Mg. So it is increasing in this direction with the angle theta. So what you can say, tan theta, that is the slope, that is equal to mg. So that is all. So if I move downward, the same body is now, let us say, moving in the downward direction by a distance of a. So at this position, u should be equal to how much? Minus mgx. So that means the diagram should be stretched in this direction. Okay. If I put up to minus 8, so u should be negative like this. Okay. So this is the variation of u versus x, that is for the gravitational potential energy. Okay. Similarly, for the spin potential energy, the variation will be a parabolic. If I do the same analysis for the spring, u versus x, the variation is parabolic one. Why? Because here this position is the natural line. If I inoculate the spring by a distance of a, the potential is positive. If I compress the spring by a distance of a, again the potential is positive. Why? Because here u equals to half k square. And I know that this number can never be negative. It is always positive number. So this variation is straight line variation. And this is the parabolic variation. This is the parabolic variation. So at any x location, the potentiality now can be calculated. Okay. Now regarding the kinetic energy, so energy possessed by a body by virtue of its state of motion is called the kinetic energy. Okay. It is defined by the symbol k, and I know that if the particle moving with the speed of v, the kinetic energy is equal to half of this. That is the kinetic energy. So since these are the energy term, all are measured in terms of joule. Okay. So this is the same example that I have already discussed. When the block or the bob is moving from one extreme point, let us say this is one extreme point to the other extreme point. So from this point onward to this point, it is performing a particular path along that path. So at the initial position here, the kinetic energy is G. Potential energy is number, is non-zero number. Okay. So at the belowmost position here, the kinetic energy is maximum. U is equal to 0. Okay, touching the ground level. Now again the kinetic energy is then decreasing. So particle were moving from A to B point, kinetic energy is decreasing, and once it is moving from B to C, kinetic energy is again. So in the situation, kinetic energy is increasing. Here the kinetic energy is increasing. Here the kinetic energy is decreasing. Okay. So at the extreme position, kinetic energy becomes 0, but at any intermediate position, there is a some kind of kinetic. Now, how to prove the expression of the kinetic energy is equals to half mv square. So, expression for the kinetic energy half mv square means that means whenever you are applying a force, let us say on a body, I am applying a force of A, okay, which is initially at rest. So, if the mass of the body is m, so can I say acceleration caused by this block is F by m? Okay. So, with this acceleration, what is the displacement? So let us say that displacement equals to A is equals to half at square in t time. That means that is equals to half into F by m into t square. Okay. So with this displacement, now I can calculate what is the work done by the capital A. So work done by capital A should be equal to how much? Force into displacement. So half into F by m into t square. That is the net work done. Okay. Net work done. Now, if I want to calculate the net work done, so once I calculate the net work done, that is nothing but the change in kinetic energy delta K. Okay. This is nothing but the change in kinetic energy. So initially kinetic energy is 0, final kinetic energy, let us say K final. So is 0. So that means that is nothing but the K final. Okay, K final number is this one. So now I am going to simplify this number. So what I am getting, F square by 2m into t square. That is the number. Okay. Now I want to calculate the velocity of the particle at this point, U final position. So it should be equal to A into T. Okay. So A is F by M into T. Okay. F by M into T. So I can modify this equation by saying half into M into F by M into T whole square. Why? Because I am putting one extra M over there. and the rest of the part is thin. So this number within the bracket is nothing but the final velocity. That means that can be written as half m v square. So that is nothing but the expression of the kinetic. So this is how I can prove that the total kinetic energy developed on the body is nothing but the work. So whenever I am applying a force on the body, so body is displaced by a certain distance, and once we calculate that distance, I can calculate the what is the work done by this capital F force, and depending on that, I can calculate also the value of work done. Okay. Now relationship between the kinetic energy and moment. Now I define the kinetic energy as half mv square. And what is momentum? Momentum is equal to P, written by the P, that is equal to m into v. Okay. So whenever the body is moving with a velocity v multiplied by the mass, that is the momentum. So from this we can say v equals to P by m. Okay. So if I put it over here, half into m means m, and v square means P by m whole square. So if I simplify it, it becomes P square by 2m. That is the kinetic energy. Okay. So kinetic energy equals to P square by 2m, or what you can write, P square equals to 2mk. That means P equals to under root of 2mk. Okay. So either I can calculate the momentum from the kinetic energy or kinetic energy from the momentum. Okay. So both are the useful equation, both can be replaced. Okay. So this is the relationship between the kinetic energy and momentum. Okay. Now comes the work energy. So work energy theorem states that according to the work energy theorem, the work done by a force on a moving body is equal to the increase in kinetic. So what is the total work? Delta W, that is net work, because the net work, that is nothing but the delta, change in kinetic energy. That is the work energy. So whatever the amount of work that I am doing, that is fully converted into increase in the kinetic. Provided there are no other forces are there which are supposed to lose the energy. Okay. So for that situation, I can use this. So if the body is like this way, let us say the body is at point A, then now it goes to point B, then C, then D, then E. At A point, the potential energy is what? Potential energy is G. Potential energy is G. Because it is on the ground, so here the potential energy. So Q at A point is G. So I don't know what is the K number. But what I can say that between A and B, total energy will be constant. At point B, the information of the potential energy kinetic energy is given. So total energy at point B is how much? Total energy at point B is equal to 100 joules. So that should be same as the total energy at point. The total energy at point B is how much? Simply 0 plus K. That should be equal to 100 joules. That means K should be equal to 100. Okay. This number is 100 and this number is 0. Okay. Now corresponding to that, what is the velocity of projection, that you can also calculate, because I need a kinetic energy of 100 corresponding to the mass of the body is given. I can calculate what is the velocity future is. Okay. Now with that velocity, the particle goes up to point B. Now moving down. Now once it comes to C, the potential is given as 50. So what is the kinetic energy? That should be again 50. Why? Because total energy has to be equal to 100. So kinetic energy equals to 50. Okay. Now between C to D, there is no change in the potential. Potential remains same. Why? Because they are moving on the same line. Okay. So if the position is not changed, vertical position is not being changed, so the particle is moving in the horizontal direction. So what you can say, the potential energy at D point is equals to, again this number should be equals to 50. And corresponding to the kinetic energy also 50. So between C and D, there is no change in the potential energy as well as the kinetic energy. Now again coming back to point E, where it again touches the ground. So since it touching the ground, the potential energy becomes 0. Now what is the kinetic energy? Total energy is 100, so kinetic energy becomes 100. So every time, if we add these two numbers, the answer is 1. Why? Because the total energy is being conserved. Now in the entire exercise, what is the assumption? Assumption is that in the entire process, there is no loss in energy. If I say there is no loss in energy, then only I can utilize this. Otherwise, I cannot. Okay. Now, that means whenever I am moving up the hill, Now, whenever I am moving up the hill, the kinetic energy is being reduced and potential energy is being increased. And whenever I am moving downward, the kinetic energy has to be increased and potential energy has to be decreased. So in the forward direction, whenever I am moving up the hill, kinetic energy is reduced and the potential energy is being increased. So at any point, the sum of these two number and sum of these two numbers should be equal. Okay. At any point, sum of the energy is constant. Okay. So there are different forms of the kinetic energy. So whenever the particle is moving along a straight line, that means this is the mass and the particle moving along this straight line. So this form of energy is called the translational kinetic energy. Called the translational kinetic energy. That doesn't mean the body will always translate. Body can perform different types of motion. Okay. So this is kind of rotational kinetic energy. So wheel is being rotated. So due to the rotation, there is another type of energy. The body is not moving. Body is not moving along the axis. So only thing is that it is rotating. So here the energy is the rotational kinetic energy. Yeah, rotational kinetic energy. Similarly, the body may form some kind of vibrations. Okay. So once I am blocking the string, so that means I am producing some kind of energy. That is the vibration energy. So that vibration energy goes inside the form of kinetic energy. So I am vibrating the string. So the vibration will create the kinetic energy over here. Okay. So now the question is that there is 500 meter of water is raised from the first floor of house to a height of 4 meter in part at height of 12 meter. To a height 4 meter to its third floor at height of 12 meter. State whether the potential in the water will increase or decrease. Okay. So 500 liter of water is raised from the first floor. So first floor is at a height of 4 meter. So from third floor, which is at a height of 12 meter, you have to raise the mass of water. So you are raising this. So once you are increasing the height, so you are moving from 4 meter to 12 meter. So potential has to increase. Okay. So find the decrease or increase the potential. So potential change. What is the potential change? That is equal to simply mgh. Now what is that h? H is this difference. H is 8 meter. So m is what? So 500 liter mass of water is 500 kg because length is given as 1 kg per liter. M is 500 kg. And if you take g equals to 10 and h equals to 8 meter, so that is the answer in joule. Okay, this much amount of potential energy of the water will increase. Okay. So in a dam, water falls at the rate of 1000 kg per second from a height of 100. So the initial potential. So initially the dam is there. So where the water is being stored, it falls from a height of this much. So potential energy over here is also simply mg. Okay, what is the mass of water? 1000 kg. 1000 kg per second into g is 10 and h is 100 meter. Okay. So this is the initial potential energy. Initial potential energy. So initial potential energy of the water is this much. Okay. Now assuming 60% of the energy in falling water is converted to electrical energy. So once it comes down, the energy will be converted to the kinetic energy. So energy available over here is the form of kinetic energy, that is how much? 60% of it. So 6 by 10 of the other number, 1000 into 10. 1000 into 10 into 10. The kinetic energy available. Now, we convert to the electrical energy. Calculate the power generated. Now, this is called the kinetic energy available per one time. What? Per unit time. Why? Because the answer for the mass is given in 1 second. In 1 second, 1000 kg of water is coming down. Okay. So I calculated the energy per unit time, that means energy in 1 second. So this should be the answer for the power then. So 10 cancels out. So 1000 into 10 means how much? 10 to the power 4. 6 into 10 to the power 4 watt. Okay, that will be the answer. But you are asked to calculate the answer with g equals 9.8. I have taken the g value as scale. You will get the answer which is close to that number. Truck driver loads some oil drums into a truck by lifting them directly. Okay. Each drum has a mass of 80 and the platform of the truck is at height of 0.8 meter above the ground. Okay. So this is the platform of the track where you have to elevate the boxes. So which is at a height of, let's say, 0.8. Okay. So what force is needed to lift a drum into the track? So 80 kg mass of drum is there. So mass of drum is 80 kg. So in order to lift that, you need a force which is equals to mg. 800 Newton. So this much amount of force you have to require so that you can lift this body. Okay. So how much amount of energy is used up in lifting a drum? So that means you are doing some kind of work. What is the work? So you are applying the force in this direction and displacement is 0.8 meters. So work done is how much? 800 into 0.8. So 640 joule. Okay, 640 joule. So 640 joule is the energy used up in lifting it. After the truck is being loaded, the driver drives on. These are the major energy changes that take place in moving the truck. So whenever I want to move the truck, so once the interloading is completed, so entire energy goes over here. So for that, what energy I'm doing, this is the amount of work that I have done. This is 42. After the truck is being loaded, the driver drives off. Means you get the kinetic energy. Okay, driver is giving some kind of kinetic energy. So these the major energy changes that take place in moving the truck. So major energy changes that once I'm lifting, the potential is being increased. Okay. So energy, potential energy of the block will increase once I lift the load on the track itself. Now the kinetic energy is being increased of the load of the car. Okay. Now the driver stops the truck at the factory gate. What happens to the kinetic energy of the truck? Once he stops it, the entire kinetic energy goes to zero. Because now the velocity is zero. So kinetic energy becomes zero. Okay. So how is the kinetic energy of a moving car being affected if the mass is doubled? Initially, kinetic energy is equal to half mv square. K final should be equal to how much? Half into 2m into v square. That means what you can say, half mv square into 4 into 2. Okay. So final kinetic energy is 2 times the initial kinetic. So it will be increased by 2 times. The velocity is reduced to 1/3 of the initial velocity. Once I reduce the velocity by 1/3 by keeping the mass same. Here it is half n, v become v square by 9. Can I say it is equal to 1 by 9 into half n v square? So it decrease by 1 by 9 term. Decrease by 9. So bullet of mass 5 gram travels with the speed of 500. It penetrates a fixed target which offers a constant resistive force of 1000. With the motion of the bullet. Okay. So bullet is moving, that means it has some kind of kinetic energy. Penetrates to a fixed target which offers a constant resistive force of 1000 Newton to the motion of the bullet. Find the initial kinetic energy. Initial kinetic energy is how much? It is equal to half into 5 gram, 5 by 1000 into v square means 500 square. Yeah, that will be the initial kinetic energy. Now, the distance through which the bullet has penetrated before coming to rest. So initial kinetic energy goes inside the wooden block. Let us say this is the wooden block. Initially the bullet is over here, so it should have some kind of kinetic. Now it will stop over here. So what is the final kinetic energy? That is zero. Okay. So now who is responsible to reduce the kinetic energy? The resistance offered by the wooden block R. Okay. So R number is given as 1000 Newton. So work done by R is how much? R into this part displacement. Okay. So work done by R is negative Rx. Why negative? Because R is in the negative direction, X is in the opposite direction. Now that should be equal to delta K, change in kinetic energy. The change in kinetic energy means final minus initial. That is equal to minus Ki. The negative number cancels out. So Ra should be equal to Ki. So the Ki is already known to us. So I can calculate X number is Ki by Ri. R is given as 1000, so Ki by 1000. Okay. So that will be the value of X in meter up to the bullet will go. Okay. The speed with which the bullet emerges out of the target if the target is of thickness of 0.5 meter. Okay. So first of all, you have to calculate this X number. Let us do that. Okay. So once I calculate the Ki number, it becomes how much? So it is 5 by 2 into 10 to the power 3. It is 25 into 10 to the power 4. So 125 into 10 divided by 2. 5, 625 joule. So the initial kinetic energy. Okay. So from that, what I am getting at 625 divided by 1000, that is 0.625 meter. Okay. Now in the question is given that the target is of 0.5 meter. So if it is 0.5 meter, 0.5 meter, certainly it is less than the 0.625. That means the now the bullet, which is initially thrown with a certain speed, will come out with some other speed v. Okay. So corresponding to what is the kinetic energy? That is K final should be equals to half m into v square. What is the K initial? K initial I have already calculated, that is equals to 625 joule. Okay. So raised to force becomes same, R equals to 1000. Nah. Work done by the raised to force is how much? 1000 into 0.5 with a negative sign. That should be equal to final kinetic energy. You are asked to calculate the half m v square number minus initial kinetic energy 625. Okay. So this is half m v square equals to 125 then. Okay. So v square becomes 250 by m. 250 by m. Okay. Now m is given as 5 gram. So it comes to as 250 divided by 5 gram into 1000. 5 into 50 into 1000. Whole root. That is v. Okay. So 3, 4 means 20 over 2. So 100 root 5. So it should be 100 root 5. That is the velocity of the margin. Okay. So this is how you have to calculate the